In the early 19th century, there were several people that all had the idea of fixing images through a camera obscura. They were working in different parts of the world and unknown to each other until at least one of their findings was published. Starting in the late 1700s, a transition in Europe's manual labor and draft animal-based economy moved instead towards machine-based manufacturing. Starting with the mechanization of the textile industries, the development of iron-making techniques, and increased use of coal within steam engines to power machinery, the Industrial Revolution was on. In the 19th century, with improved railroads and roads, steam-powered ships, and the building of canals, trade opportunities expanded throughout Western Europe and in North America. This eventually affected most of the world. The 19th century was the age of machine tools, tools that made tools, machines that made parts for other machines, including interchangeable parts. The assembly line was invented during the 19th century, speeding up factory production of consumer goods. The 19th century gave birth to the professional scientist. The word scientist was first used in 1833. The invention of usable electricity, steel, petroleum, internal combustion engines, the light bulb, telegraph, telephone, typewriter, sewing machine, all came of age during the 19th century. One of those inventions, photography, became one of the most significant events of the century. The information provided by photographs aids nearly every discipline, and combined with its current lens-based offshoots like film, TV, video, and digital imaging, photography has touched more lives than the words of the world's greatest writers and philosophers. One historian compares the only similar invention was that of writing. Frenchman Joseph Nicephore Niepce and his brother Claude, as early as 1793, began experiments with the camera obscura. By trade, Niepce was a printer, and the newly invented lithography was the rage in France. Lithography originally used an image drawn in wax or another oily substance applied to a stone, ground flat, as a medium to transfer ink to paper. While limestone was the standard lithoplate, a lack of good stone in Niepce's area, as well as its cumbersome bulk, gave Niepce the idea of switching instead to metal plates. As a printer, he was interested in duplicating existing works of art for sale, but he lacked the drafting skills to transfer drawn works onto pewter plates. Niepce turned to duplication using light-sensitive materials. He varnished his plates with a variety of substances, but his early tries met with little success, though he continued to experiment with what he called the heliograph, or sun drawing. In 1814, the brothers experimented with light-sensitive chemicals in their camera obscura. By 1816, Niepce was now working alone, started having some success. It was that year that Niepce created his first paper negative, a black and white image whose tones were reversed from those of the original scene. But like early experimenters with light-sensitive chemicals, Niepce did not yet know how to fix or stabilize the image so that it would no longer react to light. At first, Niepce simply washed the print to temporarily neutralize the development action. Later, he used nitric acid to dissolve the remaining light-sensitive solutions. Unfortunately, the strength of the acid not only fixed the print, but eventually bleached it away entirely. Nonetheless, Niepce's heliographs could be viewed for short durations under normal light. Encouraged by his success, Niepce was nonetheless disappointed that he was only able to produce negatives. But he soon tried to make a positive print by placing a paper negative in contact with another sensitized paper and exposing both to sunlight. Unfortunately, the emulsions he used were not sensitive enough for light to provide the desired effects. Niepce also tried making images using various acids on metal plates and stone. He continued to experiment without any known advances until July 1822. That year he made his first successful and permanent heliograph, a copy of the engraving of Pope Pius VII. At last Niepce had success. His process was much refined from his early tries, now using an asphalt-like substance called the bitumen of Judea coated onto glass. The bitumen of Judea was used in engraving and lithography on account of its resistance to etching fluids, and the gummy substance would harden during exposure to light. After thinning the mixture with lavender oil, Niepce coated the glass with a thin layer of bitumen of Judea. He then soaked a paper engraving in oil to make it translucent, placing it atop the glass plate. After 2 or 3 hours in the sun, the parts of the bitumen of Judea that was under the white or light clear parts of the engraving would harden, while the parts below, the black or dark areas of the etching where the sunlight was blocked from reaching below, simply would not completely wash away. Niepce soon switched from glass to pewter with the intent of making multiple copies of these plates. Niepce finally succeeded in fixing a permanent image taking out his window with his camera obscura. Know that the actual date remains in question, as some say 1822, others say 1824, still others 1826. Niepce's son said 1824, hence that's my date. The view from his window at Le Gras is a small image on a pewter plate. As you see on the screen now, this is how it's often seen in textbooks, but not really exactly what it would look like in real life. Compare that view to these others of the plate at the University of Texas collection. Niepce switched from pewter to copper, a harder metal more appropriate to make etchings. In 1829, he discovered he could make the image more contrasty by blackening bare metal with iodine vapor. In January 1826, Niepce ordered a new camera from the Chevier brothers in Paris. He asked Niepce's cousin in Paris to secure the best possible device, and with his zeal to do so, he mentioned Niepce's success in making camera images. The Chevier brothers knew of another person, Louis-Jacques Monde Daguerre, experiments also in fixing camera obscura images, and they advised him to contact Louis at once. At first, Niepce was reluctant to receive Daguerre, still wanting to protect his discoveries. After 16 months and many letters, Niepce finally relented and sent Daguerre a sample heliograph. Niepce began to write a handbook on heliography, but Daguerre learned of this and advised him against it. There should be found some way of getting a large profit out of it before publication, apart from the honor the invention will do you, he wrote. Impoverished as he was, Niepce thought this to be reasonable and suggested they collaborate to bring the invention to perfection. In 1829, Niepce and Daguerre signed an agreement of partnership to last 10 years. Unfortunately, it lasted just 4, as Niepce died in 1833, before either publication of his findings or the exact perfection of the process. The partnership was unequal from the start. Niepce supplied Daguerre with complete details of his discovery, while Daguerre initially contributed little. While credit goes to Niepce for devising the very first photographic process, it was up to Daguerre to make the invention practical. Born in 1787, Daguerre showed artistic sensibilities early on and had worked as a decorator, a manufacturer of mirrors, a painter of panoramas, a master designer, and a painter of theatrical stage productions. With an associate, they created in 1822 the Diorama. The Diorama was a popular entertainment that originated in Paris. It was a theatrical experience viewed by an audience in a highly specialized theater. As many as 350 patrons would file in to view a landscape painting on large glass plates that would change appearance both subtly and dramatically through the use of movement and specialized lighting. The result was a popular picture show known for the illusion of reality and brought Daguerre considerable fame. The show lasted 10 to 15 minutes, after which time the entire audience on a massive turntable would rotate to view a second painting, or sometimes even a third. With the fascination of the diorama's realism, it was natural of Daguerre to turn to the camera obscura. He had already used one in preparation of sketches for his diorama. Daguerre continued Niepce's experiments with silvered copper plates exposed within a camera obscura. Initially, he met little success. Ironically, Daguerre had the good fortune to fail again. After putting away in a cupboard one of his apparently unsuccessful plates to be used later, Daguerre left it for several days, only to discover when he went to repolish it to reuse it, that it contained an image. Daguerre made lengthy experiments trying to duplicate the process, ultimately finding that the results were due to mercury vapors from a broken thermometer. The fumes apparently reacted and developed the image after the plate's exposure to light. Daguerre had discovered that with a developing agent, the latent or unseen image could be processed after only 20 to 30 minutes exposure to light. On May 9, 1835, Daguerre convinced Niepce's son, Isidora, who at first was reluctant but finally agreed with Daguerre that his new discovery was significant enough a departure from Niepce's process that the entire credit for the discovery go to Daguerre. While Daguerre promptly and prematurely announced that he had succeeded in fixing the image through a camera obscura, it was actually another 2 years, in 1837, before he did so. Using a solution of common salt dissolved in hot water, Daguerre was able to remove any light-sensitive solution remaining after the image was developed. This was the final discovery that truly stabilized images from the camera obscura. In the following months, Daguerre worked to attract all the publicity that he could. He planned to profit in every way that he could and tried drumming up interested subscribers who would pay a handsome sum for him to divulge his process. Finding few takers, Daguerre instead approached some of France's leading men of science, Francois Arago among them. Daguerre's discoveries were given official status by a brief announcement by Arago at the Academy of Science on January 7, 1839. On Daguerre's behalf, after the diorama had burnt to the ground, Arago pushed for the government to acquire his celebrity friend's invention. He wrote, "Unhappily for the fortune of this talented artist, the method cannot become the object of a patent. As soon as it is known, everyone will be able to apply it. The most clumsy operator will be able to take views so perfect as those of an experienced artist. The author of so fine, so unexpected and useful a discovery has certainly done honor of his country, and his country alone can compensate him." In exchange for the details of the daguerreotype, as he called it, the French government agreed to pay Daguerre an annual pension of 6,000 francs and 4,000 francs to Isidore Niepce. 6,000 francs would be about $40,000 a year today. On August 19, 1839, as a gesture of goodwill, the French government announced to the world the details of the very first official photographic process. Unknowns to the government, Daguerre had secretly gone to England and taken out a patent, so it was a goodwill gesture to everybody in the world except the British. Upon its announcement, well-known French painter Paul Delaroche is said to have declared, quote, "From today, painting is dead," unquote. Or frankly, it freed painting from the responsibility of representation. Soon a pamphlet detailing the daguerreotype was published. It quickly sold out. Eventually, by the end of 1839, 29 editions in 6 languages were published. The process was A silvered copper plate was cleaned and polished. It was then sensitized by a vapor of iodine that combined with the silver and formed silver iodine. It was exposed to light for many minutes within a camera obscura. The latent image was developed by the vapor of mercury boiled under a spirit lamp, the mercury attaching to the parts of the image affected by the light. The plate was then soaked in hypersulfite of soda to remove the undeveloped silver iodine. It was washed in distilled water. Then it was gently dried over a flame, protected with glass, and its edges sealed to prevent silver from oxidization. Most of these were really quite small. Excitement for Daguerre's findings ran high, and the daguerreotype was celebrated. John Wood wrote, "Nearly all of these classic gems are beautiful by definition, beautiful by being what they are, bits of precious material rendering a face or scene with a detail and exactitude that, oddly enough, might only be termed Daguerrean. Indeed, the daguerreotype differs from any other photographic process, and some historians say that it is not photography at all. It is something unique, one of a kind, a daguerreotype." The Romantic period, basically 1798 to 1832, was ending at the time a daguerreotype was announced, where Romantic art favored imagination over reason and emotion over intellect. Nearing its collapse, Westerners instead turned their interest towards naturalism and realism. Naturalism is defined as a theory that holds that all phenomena can be explained mechanically in terms of natural as opposed to supernatural causes and laws. Realism is the depiction of subjects as they appear in everyday life. The daguerreotype announcement occurred during this transition and helped enhance the public's desire for the illusion of reality in its visual works. One of Daguerre's early daguerreotypes that you see here, the Parisian street in the background. One of the remarkable things of this, Paris was well populated at this time. It would have been busy in the middle of the day, but if you look at the roadway here, you see no people walking, you see no horse-drawn buggies or any of those kinds of things you would expect to see in a major world-class city. But if you look in this area right here, you'll see, and I'll give you a detail, very first person to show up in a photograph. You'll have to use your imagination a little bit, but what you're seeing is a man standing on the street with his foot up. He's having his shoe shined. He stood there long enough while all the other people in that previous image are moving during the time of the exposure, and if anything would have simply showed up as blurs. But that one person standing statically during the exposure shows up in that photograph. Daguerreotypes are mirror images. They're on a highly polished piece of metal. In fact, looking at them today, they're sometimes difficult to see. It's sometimes looking into a mirror. And again, the reflection makes them difficult to see. We'll show you examples in a later lecture. William Henry Fox Talbot, born in 1800, was a man of means. He was highly educated in the style accustomed to English gentlemen. He experimented with many of the sciences. Living near Bath in an inherited mansion called Laycock Abbey, as a man of leisure, Talbot traveled often. In Italy, he sketched with the aid of a camera lucida, but was frustrated with the quality of his results. Even with the device, his drawing skills were limited, and the accuracy of his draftsmanship was not up to his expectations. It was his clumsy attempts with the camera lucida that gave Talbot the idea to fix an image via the camera obscura. In 1833, Talbot began experimenting with the camera obscura. As Schultz's discoveries of the light-sensitive qualities of silver were well known, and Talbot was educated in the sciences, it can be assumed that he knew about this as well. Talbot's experiments began by soaking paper in a salt solution. and then in silver nitrate, which forms silver chloride, a light-sensitive solution not dissolvable in water. After drying, Talbot placed objects on the paper and exposed the lot to sunlight. Where the sun rays struck, the paper turned dark, forming a negative image. Talbot called these Talbot types, or photogenic drawings. Today they would simply be called photograms. As early as 1835, Talbot made positive images on paper from these negatives. Doing so, he would take the negative. Once it is exposed and processed, he'd wash and dry it. He'd then put that in contact with another piece of sensitized paper, placing it on top, probably putting a sheet on glass on top of that, putting it out in the sun, allowing the sun to go through the image on top, and exposing the one on the bottom to take the negative image, turn that into a positive. Talbot fixed his images first by treating the exposed paper in a strong salt solution, which partially, but not completely, fixed or stabilized the image. They became known as salt prints. Again, fixing is the ability to stop the development action or the turning dark of the light-sensitive chemical. Talbot's first attempts with a camera obscura were unsuccessful. He soon switched to a smaller camera, which required less exposure to light, thus shorter exposure times. His mousetrap camera provided images only about an inch square. Feeling no urgency, Talbot did not rush his experiments until January 1839, when he read an account of Daguerre's discoveries. Later that month, Talbot rushed samples to the Royal Institute in London, including pictures that were made as early as 1835. Talbot offered a paper to the Royal Society on January 31, 1839, and later, with even more detail, gave another paper the following month that allowed anyone enough information to experiment with his process. Prior to Talbot releasing complete details, English scientist Sir John Herschel began to experiment with what he had learned from both Daguerre's and Talbot's discoveries. Like Talbot, Herschel used silver salts as his light-sensitive solution. From early experiments, Herschel knew that hypersulfate of soda would dissolve silver salts. Thus, Herschel provided the final link to the puzzle: how to stop the development action of the sun on a light-sensitive solution. After visiting with Herschel on February 1, 1839, and with Herschel's permission, Talbot immediately published the findings, and both he and Daguerre adopted this for their processes. The chemical has since been called sodium thiosulfate and is still the primary fixing agent in film and traditional photo processes today. Some still call fixer hypo. Herschel also offered the term photography instead of photogenic drawing, as well as positive and negative to replace reverse copy and re-reversed copy. Talbot began calling his process the calotype, or occasionally the Talbot type. Calotype is Greek for beautiful pictures. Know that calotype and saltpaper prints are one and the same. You'll see that often in my titles. Unlike the French, the British government provided no compensation for his process, and indeed Talbot had received little credit for his discoveries, even though others were making a commercial success of his findings. Following Daguerre's lead, in 1841, Talbot took out a patent for the calotype. Because of the calotype's paper negative, its positive prints lacked the clarity and resolution of the daguerreotype and thus were far less popular internationally. Exposing a calotype negative, you have all the fibrous texture of paper that the sunlight goes through and indeed reduces the amount of detail or clarity in that final image. We now know, however, that the negative-positive process of Talbot's that allowed for repeatable results, meaning multiple copies of the final image, became the basis of traditional photography for the next 150 years. It's only been in the past few decades where digital imaging has now replaced this chemical-based photographic system. Nonetheless, worldwide, Talbot's process was under-recognized and less used than others during its day, with the bulk of serious calotypists occurring primarily in England and France. Though Talbot had taken out a patent in France, he never enforced it, and ironically, it became arguably more popular there than in his home country. While the daguerreotype portrait entered nearly every household, even in Britain where the process was patented, the paper photograph, later to prove so important to photography's history, was not well known during Talbot's time. Talbot continued to travel continually, making negatives during his trips. He sent them back to his wife, who with an assistant made sun prints. In 1843, Talbot set up a laboratory so as to make prints in such volume that he could tip or glue them in by the thousands into a book published through installments. In this slide, you see an example of that. You can see the photographers with their camera obscuras with a lens, a sitter who might sit for a couple of minutes, and then later those paper negatives would be put in contact with other sensitized pieces of paper exposed to the sun, processed and developed. Between 1844 and 1846, Talbot's Pencil of Nature became the first commercially published book to contain photographic illustrations. Talbot's imagery often depicted ordinary scenes and places. It exhibits the influence of the Romantics, who celebrated the doings of common people. Recognizing that not all would see the beauty within the image made in this new medium, Talbot wrote, quote, "A painter's eye will often be arrested where ordinary people see nothing remarkable." End of quote. The calotype was introduced to America in 1846, and Talbot took out a patent here the following year. Early attempts to reach an agreement with the American calotype agent failed until 1849, when the Langenhahn brothers of Philadelphia offered the process in exchange for 25% return of the profits gained from it. The two had operated a successful daguerreotype portrait studio, with President Tyler their most famed sitter. Americans didn't take to the calotype as well as the far more popular daguerreotype. With the calotype less clear than the daguerreotype and the fee Talbot demanded to use it, few Americans worked with it. Bitter over the lack of recognition for his contributions by the early 1850s, Talbot had stopped making calotypes, spending his time instead protecting his patents in England by prosecuting those he thought infringed upon his invention without paying his annual fee. By the early 1850s, a way of making negatives on glass, far more detailed than the paper negative, was discovered, though not patented. Talbot, thinking the advancement still infringed on his process, sued one of the photographers who used it after the Talbot-LaRouche case, in which the jury acquitted the defendant while also officially recognizing Talbot's discovery of the calotype. Talbot relinquished all rights to his process. He died in 1877 without further adding in a significant way to the history of photography. Born in 1801, Hippolyte Bayard worked as a civil servant in France. He began experimenting with the chemical reactions to light in 1837. After Arago's announcement of Daguerre's discovery in January 1839, Bayard hurried his efforts. Bayard's first efforts were paper negatives. But learning that Daguerre's images were positives, he set out to improve upon his process. On March 20th, 1839, Bayard obtained his first direct positive image on paper by means of a camera obscura. By the end of May, Bayard showed some of the images to Arago. In July, he exhibited some 30 images in an exhibition to aid earthquake victims in Martinique. He attracted attention, and the newspaper Le Moniteur was written, quote, "In a large frame are exhibited several examples of photogenic or photographic pictures, which have been obtained upon paper by the aid of the camera, and which have been produced by a process other than that of Monsieur Daguerre. People are already astonished at the truth of the reduced forms presented in subdued light by the objects transferred to the paper. Bayard used paper soaked in silver chloride, which was exposed to light until it turned dark. It was then soaked in potassium iodine and exposed in a camera obscura, the light now bleaching the paper and creating a direct positive, one-of-a-kind print. Arago asked Bayard to refrain from making his findings public in order not to prejudice the success of Daguerre. In exchange, Arago used his influence to get the French Minister of the Interior to give Bayard 600 francs to use towards a better camera. Bayard was upset with his government's treatment of him, and as the artist he was, he set out to express his rage through his pictures. This famous image, Portrait of the Photographer as a Drowned Man, is the example. On the back of this image, Bayard wrote, "The corpse which you see here is that of Monsieur Bayard, inventor of the process that has just been shown to you, or the wonderful results of which you will soon see. As far as I know, this inventive and indefatigable experimenter has occupied for about 3 years with the perfection of his discovery. The Academy, the King, and all of those who have seen his pictures admired them as you do at this very moment, although he himself still considers them imperfect. This has brought him much honor, but not a single penny. The government, which has supported Daguerre more than necessary, declared itself unable to do anything for Monsieur Bayard, and the unhappy man threw himself into the water in despair. Oh, human fickleness! For a long-time artist, scientist, and press took an interest in him, but now that he has been lying dying in the morgue for days, no one has recognized or claimed him. Ladies and gentlemen, let's talk of something else so that your sense of smell is not upset, for as you have probably noticed, the face and hands have already started to decompose." End of quote. Interestingly, as you look at this picture, one of the earliest photographs, a medium so enamored with reality, is created as an illusion. Following the announcement of Daguerre's discovery, the French government did listen to Bayard's claims that his process was easier than Daguerre's. The Academy of Sciences did pronounce the artistic superiority of paper over metal, and in 1842, the French Society for Encouragement of National Industry gave Bayard 3,000 francs for his contribution to photography. Bayard later was to make both calotypes and daguerreotypes. He was probably the best photographer of the inventors. He became a founding member of the French Society of Photography, which still possesses more than 600 of his prints. Some of his images still remain, you see here. Bayard died in 1887. A few other inventors also seem to have been working towards photography during this time. Hercules Florence, a Frenchman living in Brazil, seems to have made photographs as early as 1832. And while his notebooks support his claims, no known camera images survive, though there are a few remaining photograms. Also, Norwegian Hans Winther, born 1786, died in 1851, a bookseller and printer and editor by trade, also experimented with photographic processes after the announcement of Daguerre's findings, but before daguerreotype's details were revealed. Like Hippolyte Bayard, he came up with a direct positive process, and like Talbot, Winther also developed a negative-positive photographic technique, but both discoveries remain relatively unknown on the world stage.